There is an octopus in a tank at a research facility in New Zealand. It is alone. The lights are off. No researchers are watching. No food is coming, and it is playing, not hunting, not escaping, repeatedly pushing a small pill bottle into the current and catching it as it drifts back, over and over, for no reason anyone has been able to explain using the standard framework for why animals do things. An octopus has approximately 500 million neurons. A dog has about the same, but in an octopus, 2/3 of those neurons are not in its brain. They are distributed throughout its 8 arms. Each arm has its own local nervous system. Each arm can taste, feel, and make basic movement decisions independently. When an octopus reaches into a crevice it cannot see, the arm is not just an extension of the octopus. In a meaningful sense, it is doing its own thinking. An octopus can change the color, pattern, and texture of its entire skin in under a second. It matches its surroundings with a precision that requires it to be continuously building and updating a visual model of its environment. It does this while colorblind. We still do not fully understand how. Octopuses don't just camouflage to hide. They use skin displays to communicate with each other. In 2024, researchers observing octopuses during sleep recorded something extraordinary. The animal's skin flickered. Patterns moved across their bodies in sequences that were not random. The researchers watched an octopus cycle through a hunting display, then a threat display, then a camouflage pattern, all while completely unconscious. If the same thing happened in a mammal, we would say without hesitation that it was dreaming. In an octopus, we say we don't know. A female octopus guards her eggs for weeks without eating, aerating them constantly, and then dies shortly after they hatch. She never meets her children. Her children never meet each other. Everything an octopus knows, it figures out alone. In laboratory settings, octopuses solve multi-step puzzles. They open child-proof containers. They navigate mazes. They recognize individual human faces and respond differently to people they like versus people who have handled them roughly. In one facility in Seattle, an octopus repeatedly soaked a disliked researcher with water from its tank every time that specific person walked past. It did not do this to other researchers. The standard explanation for complex behavior in animals is social learning. You watch others. You copy. Octopuses cannot do any of that. Everything they know is self-generated. Every problem they solve is solved from scratch, alone, in a lifespan that in most species lasts less than 2 years. In 2022, researchers gave octopuses MDMA. Octopuses are normally asocial. They avoid each other. Given MDMA, they became interested in other octopuses. They sought contact. The researchers found serotonin transporter genes in octopus DNA that are nearly identical to the human versions, suggesting the neurochemistry that underlies social bonding in humans may exist in octopuses too. We did not give them that machinery. Evolution arrived at it separately, twice, on completely different branches of the tree of life. Eyes evolved independently more than 40 times. Wings evolved independently in birds, bats, and insects. Each time, completely different starting materials, the same solution. Nature needed something to process complex environments quickly and flexibly, and it built a mind. Not our kind of mind, something stranger and more distributed. Which brings us back to the pill bottle. The octopus had no reason to play. Play is expensive. It uses energy. We have known for a long time that mammals play. The octopus was not supposed to be on that list. It is a mollusk. Its closest relatives are clams. And yet there it was, alone in the dark, pushing a bottle into a current and catching it over and over, for no reason except that it wanted to. We do not know what an octopus experiences. We do not know if there is something it is like to be one, whether anything is happening behind those strange horizontal pupils that resembles what happens behind yours. Alone in the dark, in a lifespan shorter than a human childhood, it keeps finding new ways to surprise us. The question is not whether they are intelligent. The evidence on that is settled. The question is what kind of thing is intelligent in a way this different from us, in a body this different from ours, and what that means for what intelligence actually is. And the answer so far is that we have barely started asking it.